The topic of this video is from Unit 4D on the standard normal distribution. The normal distribution is the most common distribution used in statistics, and it describes many real-life situations. Some examples of distributions that are normally distributed are heights of men and women, SAT scores, and birth weights. Here are some of the characteristics of normal distributions. If you notice the graphic down at the bottom of the slide, the distribution has a bell-shaped curve. The mean, the median, and the mode are all the same, and they occur at the center part of your data, right below the highest point on the curve. The curve is symmetric with respect to the mean, which means the left-hand side of the mean and the right-hand side of the mean, there are mirror images of one another. The area under the curve is equal to 1. Now, since the graph or the curve is symmetric, that means that the area under the curve on the left-hand side is equal to 0.5, while the area to the right of the mean is equal to 0.5. That totals the area of 1. Now, in discussing normal distributions, we're dealing with a population instead of a sample, so we will need to change our notation. We used X bar for sample mean before, but now we're going to use the Greek letter mu to represent population mean. The sample standard deviation before was referred to as S, but now that we're switching to population standard deviation, we will use the Greek letter sigma. The standard normal distribution has a mean of 0 and a standard deviation of 1. The table of areas under the standard normal curve is based on the mean of 0 and a standard deviation of 1. Now, a z-score represents the number of standard deviations a data value is from a mean, and we can interpret the areas under the standard normal curve as percentages of the data values in the distribution. Now, we've done a lot of characteristics and definitions about the standard normal distribution, so let's actually look at the table of areas and relate it to the standard normal curve. So when you read and interpret the standard normal distribution table, which a portion of it is given to you on the screen, the Z column represents the Z-score, okay, and you'll have the heading up at the top. It'll have the letters Z or A. So the numbers under the Z, those represent Z-scores. The numbers under the A column represent the area under the curve. Now, this is based upon the standard normal, so that is the area between 0 and the Z-score. Now, notice on this table that none of these Z values are negative, and that will be true for the entire table that you will be using. Since the graph is symmetric with respect to the mean, looking up a positive 0.38 is the same thing as looking up a negative 0.38. Now, if you look at the curve here on the left-hand side of the screen, this is the standard normal distribution curve with a mean of 0 and a standard deviation of 1. So if we're looking for the area underneath the curve between 0 and, let's say, 0.46, okay, let me shade in the area that we're looking for. And it's all the area in between those two values. The table will give us that area. So look in the Z column for a Z-score of 0.46, and it occurs right here. And then look for the corresponding area. That's the 0.177. So the area here is 0.177, which corresponds to a 17.7%. So the area underneath the curve between 0 and 0.46 is 17.7% of the area. Now let's do some examples. Let's find the percentage of area under the standard normal curve that is specified. We're going to shade the area on the graph and then find the areas from the table. Now we are looking at the standard normal curve, so we have a mean of 0. and a standard deviation of 1. Now we're going to position the 2.13 somewhere to the right of 0. The area that we're looking for is the area of the shaded region. Now remember that the area from the table is based from a mean of 0. So all we have to do is to look up 2.13 under the Z column on your table. That area is 0.483. Now as a percentage, that will be 48.3%. So 48.3% of the area lies in between 0 and 2.13. Now let's look at the area between negative 1.45 and 2.01. So on our curve, 0 is in the middle, negative 1.45 will be to the left of 0, and positive 2.01 will be to the right of 0. Now the area that I'm going to shade is the area in between those two values. But when we look at the area on the table, it will only give us the area up to 0. So when I look up 1.45 on the table, remember I'm looking at positive 1.45 because the graph is symmetric with respect to the mean. I get an area of 0.427. So that's the area on the left-hand side between negative 1.45 and 0. Then when I look up the area corresponding to 2.01, I get 0.478. So that's the area to the right between 0 and 2.01. But I want the total area that's shaded, so that means I'm going to have to add the two areas together. Which gives me a total of 0.905, and as a percentage, 90.5%. So when the z-scores are on opposite sides of the mean, and you're looking for the area in between the z-scores, add the two areas together. Our next example, we're finding the percentage of area under the standard normal curve between 0.75 and 1.99. Now for this curve, 0 is in the middle, but 0.75 and 1.99 are on the same side of the mean. So when I shade the area, that's the portion that I'm looking for. And then if I look up the corresponding areas in the standard normal table, well, 0.75 has an area of 0.273. 1.99 has a corresponding area of 0.477. But since both of these z-scores are on the same side of the mean, that indicates that I will have to subtract the areas. So I'm going to take the larger number, 0.477, because it represents the larger area, and subtract the smaller area of 0.273. This gives me a total of 0.204, or 20.4%. So if both of your z-scores are on the same side of the mean, you will subtract the larger area minus the smaller area. Now let's look at an example where we're finding the percentage of area under the standard normal curve where it's more than negative 1.23. So 0 is in the middle, so negative 1.23 is positioned to the left of 0. And the area that I'm going to shade indicating more than that will be all of this area here. So when I look up the corresponding area to the z-score of 1.23, I get an area of 0.391. Now the 0.391 on this shaded part is just this portion here, to the left of 0, between negative 1.23 and 0. So to get my total area, I'll have to add something to that. I have 0.391 plus something else. Now how much area is over here to the right? Well, remember, all the area underneath the curve is equal to 1, and this represents half of the graph, so that will be 0.5. So I'm going to add 0.5 onto the 0.391 to get 0.891, which gives me a percentage of 89.1%. So anytime your shaded region contains more than half of your area underneath the curve, you do have to add the 0.5 onto that. Okay, our last example, we're finding the percentage of area under the standard normal curve less than negative 1.76. So on our graph, we of course have 0 in the middle, and then negative 1.76 positioned to the left of that. But which way do I shade for less than negative 1.76? That's of course this area right here. Now when I look at the corresponding area, so positive 1.76 from the table, I get an area of 0.461. But the area, 0.461, is this region here. But that's not the region I'm asked for. I'm asked for the shaded region. So that means I'm going to have to take the left half of the graph, the 0.5, and subtract 0.461. That'll give me the shaded portion of the area. So when I subtract, I get 0.039, which converts to 3.9%.